You have an exam next week. The format of exams, like I went over last week, for all exams, including the final, they are written. In other words, you'll be given pieces of paper, actually stable pieces of paper, that you have to write upon. So bring a writing implement, pen, pencil, whatever works for you. But it's got to be legible. Can't be small. Doesn't have to be large writing, but can't be tiny writing, as some people are wont to do. If you have any question about if your writing is too tiny, bring me an example and I will tell you. If I can't read it, it's wrong. Closed everything. That means closed book, closed notes, closed computer, closed cell phone, closed digital watch. Yes, we've actually had people try to cheat with a digital watch. It's amazing. Closed everything. You have to know the material. At the end, we will review for the exam tonight. We'll talk about this in a second. Next week, immediately before the exam, starting on the dot at 6 o'clock, everybody will be able to ask one question. If we have time to go around twice, we will go around twice, and everybody will have the opportunity to ask two questions. The questions have to be specific. It can't be, show me an example of. The answer will be no. Ask a specific question. Tonight, you can ask me when we do the review, you can say, show me an example of it. That's fine. At the beginning of class next week, your question has to be specific. Does the if statement have to have parens around the argument? That's a specific question. What happens if the if statement doesn't have parens around it? What does the argument of the if statement have to be? Those are specific questions. Review class before. This is the class before the exam. So tonight, there's a very good chance we'll finish the rest of the material and have more material to cover. So I'm going to leave it up to you. We can do it one of two ways. I'll tell you when we've covered the material on the exam. Right? I'll tell you what the stopping point is. Basically, it's everything I've written down up here. Okay? If we get that far, do you want to do the review immediately after the material? And then for the rest of the class, start on the material for the next section? Or do you want to do the material on exam 1, the additional material, and then the review? Who wants to do the review immediately after the material for exam 1? Raise your hand. Higher. Thank you. Okay, who wants to do the review at the end of the other material? Raise your hand. Okay, we're doing it at the end of the exam 1 material. Oh, by the way, it's not relevant for exam 1 because it's the first exam. But exam 2, exam 3, you can be asked anything of the preceding material. In fact, you kind of have to be. It's not that you will be asked things about the preceding material, it's that, or you might be, but it's really that you have to know the preceding material because in all computer work, new information builds on old information. Okay? So, that's just a heads up. And the final, of course, will be comprehensive before anybody asks me that. I've never heard of a final that wasn't comprehensive. That's just another, that would be exam 6. So I don't get the question, but it's okay. Everybody read the announcements. I usually think I don't have to tell people this, but turns out perhaps I do. You see, I rethink some things I haven't said out loud because I assumed them, because my 3 daughters, all of whom teach school, by now I'm starting to hear, their stories. So I think to myself, okay, maybe I should say that when it should be assumed for college students. Implicit homework. I may not remember to write it up here every time. First seat, third row. What is implicit homework?
Researching your own problem and everything you say that you don't go over in class.
Right. Well, I will have gone over it in class, but you need to read it, reread it, read your notes, copy your notes. Whatever you do to study. In other words, don't study before the exam because it won't work. This is not an ingest and regurgitate class. This is a know the material class. Some classes are treated as ingest and regurgitate, not this one. Because my objective is to get you ready for the outside world, or eliminate you before you get to the outside world, right? My real objective is to prepare you and to give you the knowledge to make your own choices about what you should do in the outside world. That's my goal. Now then, the first things we're going to do tonight will be a review of a few things I went over already, simply because they bear a second visit. Next person in the third row. What is a pointer, or what is a reference?
Pointer is something that directs to another variable.
Okay, so let's say this. That is the declaration of a pointer. Now frequently, you'll see most often in the textbook, they put this asterisk, which is the symbol denoting a pointer, next to the variable. Never understood why they do that. It doesn't make sense. Because you're actually declaring a pointer variable as really part of the type. But they do what they do in the books and in the literature. I don't know why. Okay. I do know why. Because they don't work in the real world. They're academia. That's why. I do know why. Okay. So what is the contents of this? What value will be inside this variable, this pointer variable? Let me ask it slightly differently. Well, let me digress for a moment. First of all, can I declare int and then int here with a capital I? Is this fine?
Yes. No.
Okay. Why?
It's one of the magic keywords.
The int with a capital I?
Oh no, lowercase.
The lowercase is a reserved word. So is that word okay?
Should start with a capital.
Starting with a capital I. Yes? He's changed his mind.
I did.
And he even told us why. Because capital int is not a reserved word. So back to the question, can I make this declaration?
Yes.
Yes. Okay, moving on. Yes, sir.
Would we still lose points because that's usually considered bad form according to the textbook?
No.
Okay. So it's just whatever's technically correct, not what we're supposed to do?
Supposed to do is a matter of opinion.
Fair.
Right?
All right, yeah.
Technically correct is what matters, but one of your coding standards is what?
Using meaningful names.
Meaningful name. Typically, that will not be a meaningful name, right? But frequently, you don't need a meaningful name. If you're just having a variable that you're taking something and outputting it. It has no context in the program because the program you're doing is simple. So, yeah. Academia wrote that book. But actually, I did this to make this point of reserved words. And that is not a reserved word. That's the real reason I did it. Otherwise, I might have just put X there. Third person, or the next person. What is actually contained in this variable?
Number.
A number of some sort, and in fact, an integer number. Minus infinity, well, not minus infinity, minus 2 billion, minus 2 billion roughly, up to plus 2 billion roughly. Okay. Next person. The int pointer, what actually goes in here? What
Whatever's
does it
stored in the
contain?
heap.
Sorry.
Whatever's stored in the heap is the one on the left with the asterisk is in the stack, and then array references whatever's stored, the array stored in the heap.
So the array that is stored in the heap is in here?
Yes.
No, this is a variable. This is a, like suppose your word size on your computer is 4 bytes, 32 bits. You only have 32 bits here. So what goes in here? You're getting close to the answer. Well, what is in here? Okay, one more. Next person. What is actually in here?
Like the int, the integer.
An integer value?
Uh-huh.
So what's the difference between this type and this type then? They are different.
The first one, writing when you start the coding.
The first one will have a value in it, an integer value. As it happens, the second one will have an integer value too, but it'll have a special meaning to it. Next person.
Is this a unit?
A unit? What do you mean a unit?
I mean,
It's like feet or miles or?
yes.
Second, no. Next.
I think it could be maybe its location, a reference to a location.
Its location, what kind of location? Like third house on the right location or?
Maybe wherever the value that was declared was stored
In where?
in the stack.
Well, it's not in the stack. In memory.
Memory, okay.
Memory address. That is what is stored in a pointer variable. Is a memory address. And it could be a memory address on the stack. It could be a memory address in the heap. In the example programs you wrote, called readInt, readChar, things like that, the variable you declared went on the stack, because that's just where all variable declarations go. Well, that's not true. That's where the simple ones go on the stack. But to reference it, suppose you declared TN. Let's expand this a little bit more. Next person. Next person. What would I put here to make this a pointer to this variable named int? You guys did programs for this, you must know. This is the difference between doing something and understanding it.
Percent D.
Sorry?
Percent D.
Percent?
Percent D.
No. Next person. What is percent D?
It's like referring to like the integer.
Where?
Not sure.
What function do you use it in?
You could use it in like a print statement.
Like printf, there's not a statement, right? It is a function call. It is a method call in the library. Printf and scanf are methods in a library. Okay? All of these things are important, right? Everybody should be furiously writing this down if you haven't already, so that you can study. Because when we get to exam 1, you will need to know this. Okay? Okay. Percent D is used in printf in the first parameter of printf, which is a quoted string, and it's simply, next person. What is the percent D in that quoted string? That's what it sort of represents. So when I ask you questions on the exam, I will ask you questions with the proper terminology, and you need to know what that proper terminology is. Next.
Can you repeat the question?
Okay. The percent %D, which is the wrong answer for this, we've already determined that it is used in printf, scanf too, but it's used in the first parameter, the printf, which is a quoted string. What does percent %D mean in that quoted string?
Means
Or what is it? Either one, either way to answer.
it's referable to the integer that we already, like integer x, the x refer to the percentage g.
Okay, so to digress. See, I'll walk around with the pen over. Okay, let's say we have this printf statement. What is the name for percent %D? What does it represent? Yes, I know you know. I know you know, but I'm not calling on you. I need to call on people that don't know, so they can think their way through it. What is the name of what percent %D is in that context? It has two potential names.
Variable?
Not a variable. Fourth row, first person back there. Yes, you.
Yeah, can you repeat the question?
In the printf statement, we've already determined this is the wrong answer here. See, we're going to digress and get some review in right now to try and help your grades, right? You guys know I've taught this class and I know what grades come out, right? I'm trying to help you. I really am. I'm not trying to put anybody down to be mean. I'm trying to help you succeed or help you make the right decision. I don't mean you, I mean the vast you. Okay, so it's the wrong answer for over there. We'll come back to that. Printf, you guys have used printf in sample programs. I'm sure you've all read about it intensely in your books and in other materials you can find. Percent %D, well, tell me this, what is percent %D, what happens when you have percent %D and I here?
It'll plug in whatever I equals.
Okay, it'll plug in whatever I equals into percent %D. What is the name of the thing that percent %D is? Okay, next person to his left. What is the name, or a name, because there are at least two names, that percent %D is referred to by? Sorry? Int? No. Next. Format specifier. That is the actual correct name for it. Who knows another name that is often used for it? It's not reference.
Type specifier?
Nope. It's format specifier, although it does serve as a type specifier too. Its name is format specifier. A lot of the literature calls it a placeholder. That is a bit of a dumbed down term for it, but that's essentially what it is doing. It is holding the place for I that is going to go into it. Okay, now that we have digressed, who's next? We'll go back to the original question. If I want to put a reference to the memory address of int into pint, what do I put here? Who's next? One more time?
Little ASCII symbol.
The ampersand?
Yeah.
That's okay. You can't say it right, I can't draw it right, we're all good. And then what? That's a good start.
And capital I, a little bit, capital I.
That is how you put a reference into that variable. Perhaps it'll help if I show you how printf is a method in a library that you are using. That's why it is not a statement. If is a statement. While is a statement. For is a statement. We'll get to those. We'll get to if tonight, maybe not for a while yet, but we'll get to them, okay? Those are statements because they are part of the language. Printf, scanf are method calls in a library. Remember at the, okay, let's move on to the next person. Who's next? What did you have to put at the top of your program to be able to use printf?
Studio H.
One more time?
Studio H.
Okay, what's everything you had to put there? It's not studio, it STD stands for standard. That's okay, the STD, I hate abbreviations.
STDIO.H.
That's all you had to put?
And then you need the greater than and less than sign.
Like that?
Yeah.
That all you had to put?
You need a dot. No. I think that's it. You need to include.
Like that?
Asterisks.
Pound or hashtag. That's right, in our world, we now call that a hashtag. I forgot. Hashtag study, please. At least some people find me amusing. My children found me amusing until 12, well, maybe not that old, but then I become dumb and unfunny. Pound include stdio.h. That's what you had to include. Otherwise, if you just put printf there, you get a syntax error. But once you put this there, that gives you a definition that says printf, scanf, and a bunch of other things. Okay? That's what you had to put to make printf work. Okay? Now then, let's suppose we were the writer, way back in the day, of printf method in that library. How would that have been declared? We're going to use a simple version. I don't recall if it's void or empty. We're going to pretend like it's void. This is how it would actually be declared. Not really, but in a simplified sense. You take a character array, which is what a string is, character array with values terminated by a null, and give it a name, right? And then you have to take a pointer. Now, the reason we put void pointer here rather than a specific type is because if you recall, we could do this with a char, with an int, with a float, with any number of things. So a void pointer says, I'll tell you the type later. And he tells you the type later by the format specifier he finds. But the point is, he's expecting a pointer value passed to him, which is why you have to pass ampersand int. Now I've taken the extra step of declaring it as a specific variable. In other words, in your programs, Well, that, for scanf, not for printf, actually, for printf, it would just be void p-value. For scanf, we'll call it input this time because that's what scanf does. For scanf, it would be the void pointer of where to put the value. Okay. But it's got to be a pointer because you can't just stick it in the variable you pass, which would be a value. If you passed int, you would just write it into some random piece of memory that int happens to have a memory address of. C is pretty unprotected. That's an unfortunate thing about C, but it was necessary at the time before we had all the computer resources and power that we have now. So that is why you have to do a reference. So this is the declaration of a pointer. So this is what a pointer declaration contains. It contains a reference. This is a pointer variable, frequently by convention, not always. They put a lowercase p with a meaningful name after it. Not always. That's a convention. It's not a requirement. Okay? That's how you make a pointer declaration, by declaring int star or type star, char star, whatever the float star. It's the star that makes it a pointer. And what you put into a pointer variable is a reference of some sort. Sure.
Shouldn't there be a semicolon after the statement? After both void scanf and
Nope. Because I gave them bodies. If I was just, we'll get to what you're talking about later, which is declaring the signature without a body. In that case, yes, it would have to have a semicolon.
And
We'll
those
get to
are
that
not
later in the
bodies?
class. Go ahead.
They're not the bodies?
These are bodies. They happen to be empty bodies. This is perfectly valid syntax. This would compile. Wouldn't do anything, but it would compile.
What would it give? 0?
Hmm?
What would it give? Like compile to?
It compiles to an empty body, which means when you execute this method, nothing happens.
So it would just compile with no result, basically.
The result comes from running something. Compiling is a valid syntax. So this is a valid syntax. Okay. Questions about pointers and references and what they mean. This is one of the hardest concepts to get, but it is essential because everything is built upon it. Well, not everything. A lot of things are built upon this, the meaningful things afterwards. Sir.
So what is the pointer used for?
For instance, the pointer is used to pass to a method so the method will know how to store the value that he reads from the keyboard in scanf. In other words, it's the ability to address where the value is stored. That's why it's a memory address. Whereas opposed, when you use printf, you just need the value. You don't need a pointer. So the way this actually works is when the compiler builds the call to printf, he gets the value of whatever you're passing and sticks it in the place of p-value and passes it on the stack as it turns.
So pointers are only used for scanf.
No. Scanf is one example. Pointers are used everywhere, and you will use them a lot. That's why it's crucial to understand them. Sir?
So is it used to like make your code simpler? Because it seems like you're pointing to
Nope.
specific.
It is not used to make your code simple. It is essential to make your code work at all. Are you saying could Could you write code without any pointer variables? I suppose you probably could, but you wouldn't want to.
Are there any native objects in C where you have to use a pointer instead of being able to pass a value to a function that's outside the main function?
When you say native objects, what do you mean by native objects? You mean C
So like
syntax?
usually you have to create a class and then reference that
There are no
class as an
classes in
object.
C.
I'm sorry?
C does not have classes.
Okay, so no, thank you.
C only has structs.
Well, can a struct act as a class then, or?
They're different concepts. In
Okay.
other words, you probably had C++ or something.
No.
They're different. Structs are value types. Classes in other languages are reference types.
Thank you.
So, no, they're different. So, is there anything where it has to be? I have to think about that. Nothing syntactically is immediately occurring, but to make things work right, to accomplish certain things, you want to write, in other words, you end up writing a lot. So these are methods in the library, printf and scanf. You will be, when you write programs, you write your own methods, because you don't write just one big program with go-to statements. You write modular little pieces that are methods, and you will be passing pointers to those methods as some of the parameters. So, to refer to memory that the method will access and operate on. So actually, to answer your question, the answer is yes. To pass an array, that's essentially a pointer,
Okay.
which is in the stuff for the next class, because it's in my notes to cover tonight, what an array actually is. Okay. In other words, I could have, so just to digress for a moment, I could have put that instead of char brace, or bracket, they would mean exactly the same thing. That we'll get to later. So yes, there are native things in C that's required. The real point is you have a lot of studying to do between now and next week that you should have done between last week and this week. That's why this implicit homework is not a joke. It is not a joke. That's why I put it up here. You should have studied this between last week and this week. I know a lot of you are going home and not studying at all. That's okay. We'll find out. We'll see. I always know.
Is there anything missing in the program that you just wrote? Because I tried to compile it, I got an error.
We'll worry about it later. It's not relevant to what we're doing right now. Okay, any other questions about pointers and references? Sir?
So a pointer basically takes the memory address of something and changes to a value?
A pointer simply takes contains the memory address of a variable. That's all it does. Okay. This is the other thing you have to think. You can't think in a big blob. You have to think very linearly in computer programming. Okay? So you have a pointer and it contains a memory address of a variable. Now then you might, after that, you might want to do something with that pointer that contains the memory address, like assign a value to it. We'll talk about that later. About how you dereference a pointer to put a value into it. Or dereference a pointer to get a value out. We'll talk about that later. But that is exactly what goes on when you have a pointer. Is you've created a reference, now you have to dereference it to either get the value out or put a new value in. We'll talk about that when we get to that point. But for now, you just need to understand what a pointer holds It holds a reference. And a reference is, next person. Who is next in the back row? What does a reference hold? What does a pointer hold?
What is it called?
What does it contain?
It contains the type of variable.
Contains a variable?
The type of variable.
No, a pointer is a type of variable. What does it contain? We already determined that int is going to contain an integer, right? What is an int pointer going to contain? Or a char pointer going to contain?
I'm not sure.
Next.
The pointer contains like the IP address or like the memory of the entity.
It contains the memory address. I don't know if you said IP or IT or something. Nothing IP about it, nothing Internet Protocol about this. It contains the memory address of the variable. Okay. Study and read, study and read, study and read. You have an exam next week. And we won't be doing any, show me an example of a reference, show me an example of a pointer. I'll say, no, ask me a specific question. The reason I require specific questions is because if you ask me a general question and you cannot ask me a specific question, it means you haven't studied enough for me to be of any help to you at that point, right before the exam. That's why I only answer specific questions right before the exam. Not because I'm mean or anything, because I know it won't do any good to answer a general question. Okay. Think about it. If you have a question later, we'll certainly come to it.
You said the pointer holds the reference. What about the reference? What about the reference? What does it hold?
A pointer is a reference. It's a reference to memory. It contains the reference to the memory, which is a memory address. You create a reference by using this syntax of ampersand variable name. That is a reference. That is a reference. Ampersand int is a reference to int, which is a memory address, and that is what you put into a pointer. The terminology pointer and reference are used so you have to understand what they mean. Ten minutes of break, 25 minutes of lab. We'll start again at 7:30, the fifth sequence. Okay, let's get started. So a number of you have noticed, probably, that when you ask me a question, I don't answer it. I ask you questions back. How many of you does it irritate? Oh, come on. I know it irritates some of you, probably most of you, because it's irritating, right? The reason I do it, and I told you this the first night, is because I am asking you questions that you should ask yourself. Because when I'm not here, you're at home doing your program, right? You need to pretend in your head, what questions would he ask me? This is how you discover things for yourself, okay? Because the guy's not always going to be there. Or he's going to be busy. Believe it or not, those other people at your workplace are going to be busy doing their own thing. And they don't mind questions as long as you have put in some effort and ask yourself some of those questions. Not all of them, because that's why you're stuck, right? But you've asked yourself enough to be down the path, not at the very beginning. Like, why doesn't this work? You should never ask someone that question, right? Because what the person is thinking, or what some of those people will be thinking, is going to be because you haven't tried hard enough. And they're going to be less willing to help you. I'm just telling you how the real world works. People are helpful by nature. Well, I don't know if it's true by nature. Most programmers are helpful, right? They're helpful people. They'll give you some piece of information you don't have. Because sometimes you have a valid question. Okay? What's the login to get into this site to see if my result is correct? There's no way you can know that until they help you, right? Which is a deficit on their part. They should have provided you that before you needed it. But that's another story. So that's why I respond to your questions with questions. It's called guided discovery if you go look into the teaching journal. Right? I guide you to the answer. Hopefully, if you're learning how to ask yourself those questions on the way. To some extent. You know, nothing's perfect, right? Okay. If statements. We've already done if statements a little bit. Now we're going to do them a little bit more. Actually, we're reviewing mostly. So where did we leave off back here? Who's next? You're next. Let's suppose I want to have an if statement. What is the next thing that has to be over here? What's the very next thing that has to be here?
Condition.
Yes, I know you know. Discipline. I'm asking him. What's the very next thing that comes after IF?
The parenthesis, are you talking to me?
Whoever's next. Who was next? I think he was next, right? Yes. What comes after it? Okay, next. Okay, yeah, now I'm asking you.
Me?
Yeah.
Oh, yeah, did you call it the opening parenthesis?
Yes, open paren or left paren. You can call it either of those two things. Shift 9 on most keyboards. Okay, so there's going to be something after that. What goes at the end of this?
Closing paren?
Closing paren.
You're still asking me, right?
Yes, sir.
Okay.
Close paren, right paren. Shift 0. Shift 0 on most keyboards. Okay, next. What goes in here? What goes between the parentheses?
The statement you're trying to check for if it's true or false.
Is it a statement?
Or just like,
Not a statement.
like
It's an expression. What kind of expression? Is it an arithmetic expression? It could be, but technically it's not. What goes in there is something called a Boolean expression. Which is true or false. That's what a Boolean expression is. It's something that evaluates to true or false. Next person. You defined this already last week or the week before. What's the definition of false? Because as it happens, C does not explicitly have Booleans, but it has the rules for what is false and what is true. What is false?
is it 0?
False is equal to 0. That's correct. What is true? Anything else. That's exactly right. So if it's 1, it's true. If it's 7, it's true. If it's 13, it's true. If it's -5, it's true. Anything other than 0 is true. Okay? So, that is what is in here. And anything, almost anything can go in here. Okay? Because, let's suppose okay, next person. That says int x is equal to 4. Okay? So, if x contains the value 4, will this if statement be true or false?
False.
Why? That's right, because 4 is not equal to 5, so this will return false. Now just to circumvent the mistake everyone will make as you write these programs and won't know why they don't work. I do this and don't know why it doesn't work. Yeah, today, after however many years this has been, right? Because my fingers didn't work right, it didn't get the second equal, whatever, right? Well, listen, x is still equal to 4 right here. What will this statement return? Will this be true or false? Why? What happens in this if statement?
It's just x to 5.
Say again?
Is it just setting x to 5?
That's exactly correct. This sets x to 5, and then it evaluates x. And since x is not 0, it is false. The real trick is, if I initially set x equal to 5, this will still return false, but the person who thought they put a double equal there doesn't know why. Okay? So that is the coverage of the comparison operator equal equal. It has to be 2 equals to be the comparison operator. The other part of this lesson is that you can put an arithmetic expression in there, it'll execute it, and then evaluate the value. That's just how C works. Is this a good thing? It is not a good thing. But C, C++, C#, they all work that way. Not a good thing. C# will frequently give you, will typically give you a warning. It says, are you sure? And you'll look, oh, probably not.
So if you put a double equal sign right now, is it gonna be true because it's saying x is equal to 5, or it's not setting x equal to 5?
If you put a double equal, it is not setting x equal to 5. So you tell me, will this be true or false?
That would be true
Why?
because x is equal to 5.
Because x was set to 5 up here, and 5 is equal to 5. So it would be true. Okay. That's all there is to if statements. Sir?
When you said x equals 5 without the double equal, did you mean it would equal true or false?
What do you think this would be equal? What do you think the evaluation of the if statement would be, true or false?
True?
It would be true, yes.
Alright.
Because the value that it's evaluating in here is 5, because you assigned 5 to x. If I said it was false earlier, I was mistaken. I said it wrong. This would be true, because x takes on the value 5, and then if 5, which is not 0, means it's true. Did I see a hand? Yes.
If we put the value for x, if we put the value for x, and after that you ask the user to enter a value, which value x will take?
Depends on what happened last.
What happened?
The last thing that happened is what it's gonna be. So if you said nx equal to 5, scanf, you know, what percent %d, ampersand x, it's gonna be whatever the user entered. Things are linear. The thing about computers are, they are linear, and they are, this happened, then this happened, then this happened. They are discrete things. We have to think of them as discrete steps. Any other questions about this? Okay, so that's the equality operator, equal, equal. Not equal. Let's start up here on the side and go down the side. Not equal. What do you think? Which is exclamation mark equal sign. What do you think not equal does? Does not equal. So it does exactly what it says it's going to do. So in this case, what will the if statement evaluate to? True or false? I said x is equal to 5 up here. I know it's hard to see over there. I said x equal to 5 before the if statement. If statement says x not equal to 5. True or false? False. It is false. Because x is in fact equal to 5. That's all there is to not equal. Pretty straightforward. Next, with the crutches. Sorry, that's no fun. I've done that before. I've ripped my plantar fascia. It was worth I was playing Frisbee football. I played barefoot because I could run faster. And as I was running, I heard it rip. It was pretty gross. I didn't feel it till I stood on it. But the important thing is, I caught the Frisbee that had been thrown to me. But then I couldn't get up and walk, so. But I caught the Frisbee. That's the important part. Then I was on crutches for a while. Doctor said, "You're playing Frisbee football without shoes? Are you an idiot?" That was a rhetorical question. The answer is, yes, I was. Some people will say I still am. Okay. X. We'll do a few more comparison operators. What do you think that comparison operator is?
Less than or equal to?
Less than or equal to. Is that true or false?
True.
Okay. Another operator, since I have you, what is that operator?
Less than?
Is that going to be true or false?
False.
Why?
Because x is equal to 5 and 5 is less than 5.
That's correct. What's that operator?
Greater than or equal?
Right. True or false?
True.
Correct.
Greater than?
Greater than. True or false? False. Because 5 is not greater than 5. It's not rocket science. Go read it. Go home and read it. Right? Because those are simple, right? You get it right now. A week from now, you'll be like, go read it. Hang on, let me look at my list. Okay, got this. Okay. Any questions about the comparison operators? That's what those are, comparison operators.
Yeah, the exclamation mark indicates that x is not equal to the integer that's after that, right?
Yes. It compares the two and not equal as a comparison.
Are these all the comparison operators there are, or no?
Yes, Those are all the comparison operators. There are more Boolean operators that we will talk about, but those are all the comparison operators. Equal, not equal, less than, greater than, less than or equal to, greater than or equal to. We're also going to talk about a unary operator.
The one that is greater than or equal to is the one that has like a dash under the sign, arrow sign, right?
Nope. It has two characters, greater than character and an equal character. There is no, yeah, I know in conventional math, you guys will talk things like this. Right? There's no way to express that on the computer keyboard. So they did that. Okay. I mean, they could have made the keyboard, you know. And there are all sorts of keyboards. There are Italian keyboards. There are Cyrillic keyboards. There are Hebrew keyboards. There are Arabic keyboards. There are kanji keyboards. The list goes on and on and on, right? We're not going to get into that in this class. I don't even know if we get into it in any class here about character code. Well, ASCII, I told you to look up ASCII. Who looked up ASCII? Yeah, that's sad. ASCII is a character code. Okay, comparison operators, that's all the comparison operators. Now we're going to talk about the last thing about if is you can, but it is not required, have an else with the if. If this evaluates to false, the code for the else is done. If this evaluates to true, the code for the if is done. Simple as that. If no else exists, then it just goes to straight line code. Let's suppose no else exists. If this is true, the stuff inside of here is executed, and then it just continues executing. If this is false, the body of the if is not executed, and then it just continues executing. Okay. Let's talk about comparison operators. Let's talk about the unary not operator. Okay? Okay. Next person. What do you think this, I put parentheses around the x greater than 5. What do you think the not operator does?
Can you repeat that?
Okay, I simply added parentheses around the x greater than 5 expression. And then I put a not, which is simply an exclamation mark, in front of it. What do you think the not operator does?
I think so.
You think so what? What does it do?
I'm not sure.
Next. I can't quite hear you.
I think that the fact that you just put it outside the parentheses, it might distribute to the x and the 5, so they don't.
Okay, so when you put something in parentheses, whatever's in the parentheses is executed as a unit. So x greater than 5, assume x is equal to 5. What is x greater than 5 going to be evaluate to, true or false?
True.
X is equal to 5. X greater than 5.
Oh,
It's false. So what do you think not false means?
true.
True. So if I put in here x greater than or equal to 5, what does the x greater than or equal to 5 evaluate to? Just the x greater than or equal to 5.
Would it be false or it's not, or would it be
Forget the not, just the thing in the parentheses.
true?
It's going to be true, because x, 5 is greater than or equal to 5. So that's true. Not true is what?
False.
False. It simply reverses whatever the expression ahead of it is. That's the unary operator. Unary means it only takes, binary means it takes 2 parts. Unary means it takes 1 part. That's why it's called a unary operator, because it operates on a single thing. It turns true to false. If this is false, it turns it to true. Okay. Next. Is the if statement true or false? If you neither, it's one or the other. It's a compile error, or it's true or it's false. Is it a compile error?
Yes, it's a compiler.
Nope. It's not a compile error. So now you're left with true or false. You have a 50-50 chance.
We go false.
X is equal to 5. So is x equal to 0?
No.
The only thing that's false is if it has a 0. So x is equal to 5, so what is it?
True.
It is true. Okay? This is a sloppy part of the C language, which is inherited on to C++ and C#. I'm not sure if it's inherited on to Java, because Java is derived from C ultimately, but it's still sloppy. You know what's sad? People still write code like this. Not if I'm the code reviewer, they don't. Wrong. Fix it. Make it meaningful. Even if they need to write I make them write it so it's clean and clear and expresses itself. Self-documenting code. Yes?
Is the extra closing parenthesis part of that, or is that just not?
That wouldn't compile, right?
I wouldn't have compiled the way I had it.
So right now, would it be false, now that it's saying x is not equal to 0?
5 is not equal to 0. It's false. Because 5. X is 5. Oh, wait a minute. 5 not equal to 0? That's actually true. Because I wrote it so that this was the same thing as this. 5 is not equal to 0? That's true. The value 5 is true, because it's not 0.
So if we only had an x in parentheses, is that saying that x is 0?
So when I had this, what's the value of x?
5.
So what does this evaluate to?
Is that saying that that's saying that it's 0?
Why is it saying it's 0? What's the value of x?
X.
No. I set it to a value.
Oh, 5.
So therefore, what does this if evaluate to? True or false? What is false?
0.
What is true?
5.
Everything else, right? Is 5 0? Is x 0, or is x part of everything else?
Everything else.
So therefore, what is this?
True.
True. I've always hated this about C, right? But it is what it is, right? I was in diapers when C was written. Well, that's not true. I was probably a toddler by then, barely. Okay. Next person. Now what does that if statement evaluate to?
Not X.
Not X is true. Is it true or false?
It's not 5. False.
That's correct. What it actually does, it evaluates X, which is what?
5.
It's 5, but in the sense of it, is it true or false?
5 is true.
5 is true, so it's not true. False. This whole expression, this expression is false. Okay? Go read it, write down examples. Write down a page full of examples and go through them. Is it just random examples and decide if they're true or false? There's no other way to learn this, right? There's no other way. I'm a physicist. I very naturally abstract things, right? Who here is a physicist? Right. And it still gets me sometimes, because I forget everything else is true. I don't forget that, I just don't think it through sometimes because I'm in a hurry, right? That's the thing about computers. You have to be meticulous, you have to be very step by step, you have to be very linearly oriented and finely oriented. Don't think about this, think about this. Because after you think about this, there will be the next little thing to think about, and the next little thing to think about. And yes, in high school I was thrown out of the physics class for correcting the professor. And then he'd come apologize and say, okay, you were right, but you don't need to correct me in class. So then I say, so you want to tell the student something wrong? Mr. Mazingo didn't have an answer for that. He and I ended up coming to be good friends, as much as teachers to be friends. But was I pushing his buttons? Probably so. Probably so? Almost certainly so. Okay. Questions about it? Questions about comparison operators? Sure.
The exclamation mark, if it's before the X, it means that it's, if the equation is not equal to the integer on top, or is it vice versa, if after that?
No, it changes whatever's behind it. Whatever's behind it is true, it becomes false. Whatever is behind it is false, the evaluation is true.
So what's the difference if the exclamation mark is behind the X on top?
That's a syntax error,
Why is that?
because that's how the language is defined.
Oh,
It doesn't make any sense. There's no meaning to it. Could they have made that equal? Probably, but they didn't. They defined the language how they define the language. They don't care what I think. They don't care what you think. They don't care what anybody thinks. Not that they don't care, it's that it's a language that grew and evolved. Not everything grows right. Not everything grows, but there's always reasons, right? Trying to conserve memory, trying to conserve keystrokes, all sorts of things. Back in the 1960s, they were trying to go to the moon. We had to write stuff like this. Sir?
Would it be a syntax error if when you have like the full expression, like x is equal to 5, and then you put the not operator in front if you didn't put it in parentheses?
So if you did this.
Yeah.
Okay, that talks about operator precedence. I will never talk to you about operator precedence because I always want you to use parens. If it was me, I would change the compilers to give an error anytime you do not use parens. there is a precedence of operators. I don't happen to remember this precedence because I always use parens. And if you do not use parens, you'll get a 0. Simply because, why remember that? Just write the parens. Makes it clear for the next guy too. He doesn't have to remember precedence. Listen.
I have a question. Can you use multiple arguments? For example, x between like 0 is less than x is less than 10. I mean,
Anything like that? Yeah, you can do things like that. We'll talk about Boolean operators later. You can write more complex expressions in there, yes. We'll talk about it later. Okay, questions about if, comparison operators, the unary not operator. Okay. Now the next thing we're going to talk about go together. The char type, and that's some of you want to say char, you almost can't help yourselves. So think about what it means. It means a character type. And it's the abbreviation char. Now should the English language pronounce CH with a hard K sound? That's the English language. Sorry, we're stuck with it. Character types, and single versus double quotes. Hopefully you'll remember format specifiers and placeholders now. The char type is actually a numeric type. It is a form of integer. You have int. Forms of integers are int, short, long, and char. A short is typically half of an integer in size. A long is twice of an integer in size. A character is half of a short in size, which means it's a quarter of an int in size. It's not always true, this is just a typical case now. In other words, it's 8 bits. It contains an ASCII character, but it is a numeric type. You can also put 3 into it. I haven't tried this in the compiler. I'm sure someone will try it in a minute. I bet you that will compile just fine. Because a character, a char, is an integer, is a numeric type, and is an integer type. So, in some of your efforts, you came to see that single quotes and double quotes were different things. Single quotes are only used for denoting numeric values for character type purposes. So some of you said char C is equal to quote a quote with double quotes, and you got a syntax error. Did that happen to anyone? Happened to some of us. It happened to me, because I'll forget. Others of you also tried to use printf with a string with single quotes and got compile errors. Anyone? That happened to anyone? I know it happened to some people because I rated your thing 0 and then you went back and corrected it. right? Which also told me that unfortunately, you weren't testing your code. I didn't care that you got the single quote versus double quote wrong. I really cared that you didn't test your code. That means it is unlikely you will succeed in this class unless you have had a vast awakening. If you think you can write code and not test it and have it be right, go ahead, see what happens. I know what happens. I almost fired a guy for checking in untested code. I wrote him up for it, and then he told me, we'll have to agree to disagree. And I said, oh, actually we don't. You want to rethink your statement? He rethought his statement. I will test going forward. I said, good, that's what I wanted to hear. Because he knew what the next thing that was going to happen was going to be. I was going to send him back to his desk, walk into HR and fire him. So, fortunately, whether he believed it or not, I don't know, but he said the right words. When you're doing HR things, that's all you can do. Okay, single quotes are for expressing a single character as a number. So when you say single character, so let's suppose I do this. Char C gets 1. What do you think value, who's next? After Mr. Guzman. What do you think value gets put into C? Will it be a binary 1? Yes or no? 50-50 chance. Do you think a binary 1 will be put into C? The variable C? No. That is an ASCII 1, which has, if I remember correctly, it is either decimal 31 or hex 31 or octal 31. I forgot which. I think it's hex 31. Actually, I can look it up and tell you. That's the wonderful thing about Google. How did we ever survive without Google? Believe it or not, we did. Someone thinks it's hex 31? That's what I think it is. But I'll know for sure in a minute. ASCII code for 1. Therefore, in order to print the ASCII value of any digit, 48 is required to be added to the digit. So it's 49. 49 is hex 31. It's decimal 49, hex 31. My memory was actually correct this time. It is a hex 31. Frequently, hex 31 is represented like that. It means the first 4 bits have a value of 3, second 4 bits have a value of 1. We're not going to talk about hexadecimal code. The real point is that it is not binary 1. It is the numeric value corresponding to this character in ASCII. That is what the single quotes mean. Okay? The numeric value corresponding to the ASCII character in the single quotes. That is what actually gets assigned. Now for our purposes, right, char variables and char arrays are almost always used for letters and numbers, for keyboard things, for strings, okay? So for the most part, it doesn't matter. We rarely use it as a number. You just need to know that in the definition of C, it is a numeric type, and that is why you have to use single quotes. That's the real point. That's why you have to use single quotes and double quotes don't work. When you're doing a character array, that means it knows you're using a string for which you have to use double quotes.
So if it says declare a character variable, do you go
I would go char A, because it stands for character.
Oh.
But, yeah, you say char A, you mean you want to assign a value, to initialize it to a value? Or just declare the variable? Just to declare a variable, char A, semicolons, declared a character variable called A. If you want to assign a value to it, you're assigning a number to it. You can assign a number by giving it a number, 13 or whatever. Or you can express that number as an ASCII code by using single quotes. Are you guys beginning to see why they make you take C? On the surface, C might look a little simple. But when you understand what's really going on, it gives you lots of fundamentals about computers and how they work, if it's taught correctly. I know it's not taught correctly frequently because I see people in data structures who have no clue about these concepts. Yes, sir?
Is ASCII on the exam?
No. You mean the concept of ASCII, what ASCII is and so forth? No. But the concept of that a character type variable is actually a number and the single quotes are meaningful as opposed to double quotes, yeah, it's all part of the material.
Or I guess are like the actual variables, the numbers on the...
No. No, the character encoding, that's what that's referred to. No. I'd never put that on any exam. I couldn't remember for sure what a 1 was. So
So how come we don't have the single quotes to get an error?
you mean if it was like this?
Yeah.
You'd get a binary 1 assigned to that character variable. If you tried to print it out, it would print out, I don't know what it would print out. I don't happen to know what a binary 1 is in ASCII. I'd have to look it up, but it wouldn't work if I tried to print it out. Okay, that's character variables and double quotes versus single quotes. Any questions about how the exam is going to work?
I actually had a question about what we were just talking about.
Okay.
When you said char C equals 1, you said it was the binary 1.
Yep.
So wouldn't it be the hexadecimal 1? So if I assign 33 to it, would C actually equal that letter of whatever 33 was? Or 31? Or does 1 literally mean...
Let's say 49, which is the decimal representation of hex 31.
Okay.
Those should be equivalent statements.
Okay. Thank you.
Any questions on how we're going to do the exam? Tonight we're going to do the review. For the exam, each person can ask at least 1, possibly 2 questions. Maybe 3 if nobody has questions. I'm glad you have questions, by the way. That's a good thing. Questions? Knowledge starts, knowledge begins with the words, I don't know. And then asking a question. That's where knowledge starts. That's a good thing. And then there will be lecture after the exam. In case anybody, it's not the whole period. In fact, you don't even get an hour to take the exam. It's not that long of an exam. The way here's how long you get to take the exam. I take the exam, and I take it very meticulously, slowly. For instance, if it's multiple choice, even though I know the answer, I will read each one carefully and slowly to myself. And I'll take time how long it takes me to take the exam. It's a matter of discipline. I've learned the discipline over the years, how long it takes to do things slowly. Okay? You have 50% longer than it takes me to take the exam. The reason is, typically, you either know the answer or you don't. For some of those things, for some of the things that you have to work on and puzzle out and write code, I'm even more meticulous in taking my time. Right. So you end up having plenty of time to take the exam. The reason I put a limit on it is because there are people, if I say you have an hour and a half to take a 15-minute exam, there are people who will sit there an hour and a half. That's why it's limited. Okay. Switch statements are essentially, you can think of it as functionally multiple if-else statements. But they are not actually, the compiler does not actually generate code like that. This is the format of a case statement, of a switch statement, sorry. So if I say switch y, it takes the value of y and goes to the right place and starts executing code. So let's take this simple example before we get into more complex things. So if y is equal to 1, let's go down this side. If y is equal to 1, what do you think is going to happen as execution proceeds? Yeah, you may have to stand up, sorry.
Sorry, can I repeat the question?
Okay, this is a switch statement. Y is going to equal to y times 2. Suppose y contains an initial value of 1. So y is going to be y times 2. So when you get here, y is going to equal to 2. What do you think is going to happen?
It's not gonna compile since you said y equals to 2 and then on top you said y equals to y times 2, which is
Oh, it'll compile.
1.
It will compile.
Oh,
Yeah, because this is a variable. Who knows what y was equal to above here? The next time it comes through here, y may have a different value. So as an example, suppose y is equal to 2 when it gets here. What do you think it's going to do? Do you think it'll go to case 3? When y is equal to 2?
no.
Will it go to case 4? 50-50 chance. Y is equal to 2. We'll start executing the code under case 4.
I think it could.
Why? Why would it? It's equal to 2. This is the case for 4. So it would not execute this code. Do you think it would execute the code for case 5?
No.
Do you think it would execute the code for default?
What does it say?
Default. Sorry, terrible word. 50-50 chance.
For the default statement?
Yeah, well, it would execute the code here. Just guess, yes or no.
No.
No, it will in fact execute this. Because you can think of the default as the else. If it's not any of these, it will do what's in the default. Okay?
Does the default mean like the original statement?
Nope. Default says, if it's not any of these cases, do this. All it means. Think of these as all ifs. This is the else. Default is equivalent to the else. If it's not any of these, do the default.
What's the purpose of the default if one of the cases is true?
Then if one of the cases happens, it executes that case. Doesn't do the default. Well, we'll get to some wrinkles here. Okay. Questions so far? Yes, sir.
Why use the switch instead of the if else?
Because it's much more efficient.
All right.
It can be much more efficient. Number one. Number two is more clear.
It is. All right.
Yeah.
Do you have to go in order? For example, you went 3,
No.
4, 5.
Nope.
And the second question is, you're using a break statement. Usually that breaks out of any
Talk
loop.
about break in a minute.
Okay.
Yes.
I'm sorry, what determines which case executes again?
The value here goes to the associated case. So if y was equal to 2 when we started, and
Just the integer
y
value.
times 2 is 4. So if this is 4, we'll come back to that. Just do the integer case for now. So let's suppose y was equal to 4. So we'll start executing case 4 and execute the code here. Okay? And not execute the other cases, except for the wrinkle we're about to get to. Break. What the break statement does here says stop executing the switch statement. That is what break does. Now in C and C++ is implemented horribly. Because if you do not have a break statement, like in case 4, it will just keep executing until it encounters a break statement or it exits the switch. So the answer is always use a break statement. Always, always, always. Sir.
But if the switch statement is inside of another loop, would it also break out of the loop?
Nope, breaks operate on the most internal thing relevant.
Okay, thank you.
Thing closest to it is relevant. So don't worry about for loops, we're not talking about for loops. Just switch statements. We'll talk about for loops next class. Or maybe this class. Okay? Always use a break statement. Always use braces. You don't have to use braces, but always use braces because it makes it clear. Now in C# in Java, they fixed that. If you do not have a break statement inside of a case, you will get a syntax error. Which makes it almost pointless to put the break statement there. They should just say it only does what's inside the case. But they had to stay with the flavor of the language. So that's just the way C# and Java work. C and C++, if you do not put a break, it will fall through and keep executing until it encounters a break. Know this. The reason you need to know this, the reason it's important, is because you will write code and you will forget to put the break statement in there. And you will not know why your program is malfunctioning. That's why you need to know that. Again, I was a toddler when they called and my mother probably hung up on them to ask my opinion about that. That's a joke. Not very good. Okay? That's how a case statement works. Simple as that. To someone's point, yes, you can write if else, if else, if else, and get the same thing. There's another thing. You can put two cases together like that, and this will be if it is 2 or if it's 3, it will execute this. Okay? Which you could just have an if statement that says if y is equal to 2 or y is equal to 3, then else if, else if, else if. It would functionally run the same way, but this runs actually much faster. Why does it run faster, you might want to know? Or probably you don't, but I'm going to tell you anyway. It's because what it does, the compiler generates a branch table. So he evaluates it, he uses the evaluation here to index into the branch table, which takes him straight to the place he needs to execute without doing all the if-elses. That's why it's more efficient in some cases. That's why it's more efficient in all of C and C++. Yes. Question?
How do you know where to use the break statement?
You use it at the end of the case.
Isn't case 4, I don't think was it used in case 4?
I left one off of case 4 for the purpose of explaining that it would continue on to, it would execute this and it would continue on to case 5 until it reached that break statement. That's why I left it off there, to illustrate that.
What if we want 2 statements to each write the same?
You mean the and not the or case?
Or case 2, but we
You
don't
can't do that with the switch statement.
What?
You can't do that with the switch statement. That's why it's not strictly speaking taking the place of if else. If you have a complex if, it's not true. Sorry.
You could fit other statements within a case, right?
You can put any statement you want inside of here. Yes,
If multiple breaks like cross.
yes. Because the break is a statement. It says, leave the switch. That's what break statement means. It'll mean other things that we'll talk about later in other contexts, unfortunately. But that's what it means in this context. Had they called my toddler self, I'm sure I would have told them, pick a different word. So that the words don't mean, well, they kind of mean the same thing in different places. I would have had to pick different words for the different places. No, I was drooling on myself, I wouldn't have said that. No. Okay, that's a switch statement. That's really all there is to it. Except for your implicit homework, where you will go read about it. You will go give yourself examples. You will understand how it works. If you don't spend at least an hour doing implicit homework on the switch statement, you have not done your implicit homework. The default is not required. The default is not required. So the question is, what happens if you do not have a default? Suppose this default is not here. Why does some eraser sit in my hot car and quit and some eraser, I don't know. Suppose you do not have a default here, so we'll get to the next person on that side. Let's suppose you have 2, 3, 4, 5 as the cases in here. Suppose y ended up being 7. What do you think would happen when the switch statement is executed? No, the default's gone. It does not have a default. You're right, if the default was there, it would do the default. But if there is no default, which is valid in code, what do you think would happen? One more time? I can't hear you. I still can't hear you. Do you think it would run validly and execute the next statement after this?
No.
It would not. In fact, it would give you an invalid index. That is the error you happen to get. Because the way this is actually compiled, remember I told you it built a branch table? That's a table that it indexes into. And it would not have an index for 7. So it would get an invalid index. Just like if you declared, well, that's not true. C doesn't work that way. But that's what would happen. You would get an invalid index. And your program would error out. Okay? So, the other rule is, the other convention is, always have braces, always put in a break, always have a default. Even if the default is log, we should never have gotten here. Always have a default. So you at least detect something that shouldn't have happened, did happen.
So the default always counts as pretty much the last case.
Yes.
And then what's the purpose of the default instead of writing case 6? How is it different?
The default is anything else. Anything that's not one of the cases. That's what default. That's what the default goes for. Anytime it evaluates to anything that is not one of the cases, execute the default. Implicit homework. Go home and read it. Study it. You can ask me a question at the beginning of next class. What?
How do you know which case is going to work?
It's the value of y. If y is equal to 2, it'll execute this. If y is equal to 3, it'll execute this. If y is equal to 4, it'll execute case 4. Right? It's that simple. This is the integer switch. There are more complicated switch called enumerations that we'll talk about later. Sir?
will y be already given to us, as in the value of it?
Of course. Yeah. There are no trick questions. If you have to have a value, you'll be given the value. Yes, sir.
Can we put strings in case?
Sorry, one more time?
Can we put strings in the case?
How do you distribute the case?
Can we put strings?
Can't use a string here.
No?
No?
What about chars, like characters?
Yes, that's the numeric type. Any numeric type will work. Including enumerations, which is a numeric type that we will talk about later, not for this test.
Even decimal?
I'll have to look that up, I'm not sure. That's a good question. I kind of don't think so. I think it's only integer types, but I will look. For the purposes of this exam, only integer types. But I will look up that question and get back to you. That's a good question. For the purposes of this exam, integer types.
So like if the case number is 4, or like something there would be 8 because of the y equals y times 2 right up there.
If y was 4 up here, then it would become 8. So switch 8, where would it go?
Because it's not there as a default.
It would go to the default. Or if the default wasn't there, it would get an error. Not a compile error, a runtime error. Some errors can only be detected at runtime. Compile errors are easy. The compiler tells you, right? Okay, I gotta go fix something. Runtime errors are much more difficult. You gotta figure out why your program's wrong. Switch statement questions.
So instead of writing all the cases, why not just write one case and then write the default right out of it? Does it mean anything else? Or is that going to be a syntax error?
I don't think your question makes sense. You want to execute the code for these cases exactly as it's written. That's why.
But if it's going to be 8, then why? How's that gonna
It's not compile. You don't know at compile time what the value of y is. It's the runtime value. That's why it's a variable. Variable means the value can vary. That's where the term variable comes from. Means it can vary. Vary means change and be different. That's what a variable is. Any other questions about switch? Fill out your implicit homework. Have your questions, your specific questions, ready for the beginning of next class. You only have one question. Plan on having one question. You may have 2, you may have 3. Plan on only having one question. Because there's so many more. Okay. Last 2 subjects, ternary operator and variable names. We'll do variable names first. Those are easy. This will be easy. Don't ask me why. It's what C requires. Okay? But don't ask me why C requires it. It just does. C cannot be a reserved word. The reserved word you know about so far are if, else, switch, case, all the variable types like int, float, double, so forth. Can't be any of those names. Except for that, it can be any name that you choose that starts with a letter or an underscore. That's the only thing a variable name can start with. A letter, capital or not capital letter, any of those 52 letters, capital A and lowercase a are different. Because remember, Variable names are case sensitive, or it can start with an underscore. After that's what it starts with, a variable name can contain a letter, a number, or an underscore. An underscore is not a dash. It's not a minus sign. It is an underscore. On your keyboard, an underscore is shift dash. Might have been an unfortunate choice when you're typing quickly, but it cannot be a dash. It can only be a letter, a number, or an underscore after the first character. The first character must be a letter or an underscore. Those are the rules. Just look them up and does them. Fortunately, you'll get a syntax error if you don't follow the rules, unless you're taking an exam where you don't have a compiler available to you. Okay? That's variable names.
You said after first letter, you can contain letter, number, underscore after the first character.
Yep.
First character as in the first letter in the character. But like
First character. First character in the name. Letter or an underscore. Second and subsequent characters can be a letter, a number, or an underscore.
Like words? Characters, like the first
A character is A, character is B,
Oh, okay.
character is C. But you can concatenate those characters to make a variable.
So it has to start, it has to go after the first character, whichever like letter, number, underscore.
And then you can put anything you want there. That's a letter, a number, or an underscore. Okay? Those are variable names. Ternary operator. The ternary operator, let's suppose you write this. Perfectly valid C. If x has the value of 5, then assign y to a value of 13. If x does not have the value of 5, assign y the value of 14. You can write that same expression by saying this. Those are equivalent. This is something that's commonly referred to in the industry as syntactic sugar. In other words, it allows you to write code more compactly, more easily. You see this takes 1, 2, 3, 4, 5, 6 lines. That takes 1 line. Okay? But that's how the ternary operator works. It takes a Boolean expression and returns the thing after the question mark for true. It returns the thing after the colon for false. That's all there is to it. That's fairly straightforward.
What do you call it? For the C programming language, can you only use ternary operators for expressions, or is it like in C#, or is it like JavaScript where you can just use floating ternary operators?
Nope. Only. So the answer is no. It's not like JavaScript. If you're for no JavaScript or Python, please take that out of your mind. Seriously. Those languages that shouldn't exist, they cause more trouble than they solve problems. I'm pretty sure it's only numeric expressions. Right. In other words, this will have a type, and I believe this has to be a numeric type. I'm almost certain of that. For our purposes for the exam, this will only be a numeric type, which means these can only be numerics. And these don't have to be literals, they can be variables, right? It just has to result in a numeric expression.
I don't really get it.
Is shorthand for this if else.
Doesn't.
So, study, read your books, be prepared with your question next week.
Not be able to separate examples.
Nope, these are equivalent examples. This is one way to write that, write this code. This is another way to write exactly the same code with a ternary operator.
Which one do you rather us use? Or prefer us? Or could be whatever, whichever.
It doesn't, well, in this case, this is more compact and succinct, right? I would rather you use what you understand. Hopefully you will understand this by the time you've read a little bit about it. This ternary operator is simply a shorthand way of doing this, of doing an if else. It's called ternary because it has three parts to it. It has the assignment part, the evaluation part to one of these values.
Yeah, for the output where it has the for true and for false, does it have to be a specific like integer? Or could that be another expression?
It'll be whatever, it can be an expression. In other words, instead of 13, could it be z times x? Sure, absolutely. It can be any numeric expression.
So anything after else is pretty much false.
After this else,
Yes.
so if this is false, it executes the else, the body of the else. That's how an if statement works. Simple as that. So, when I use the words as simple as that, if it is not simple to you, particularly after reading a little bit at home, that's important information for you to have. And these are the easy, simple parts of C. It gets more complex from here. Pointers and references, we're going to start using them in lots of places with lots of different things. Structures, all sorts of other things. Okay? So understand how this statement works, the if-else statement right here. This is the ternary exact equivalent of this is the if-else statement. Make sure you understand why. That is the end of the material for exam 1. 8:50. 10 minutes of break. Do 15 minutes aloud. We'll start again at 9:15 and review material for exam 1 that we have not reviewed tonight. Fortunately, we reviewed most of it already in the course of it, but there were a few things we'll go over again to be sure. Okay, 9:15.
Something to do with text.
Okay, the review. This is the reviewing anything we did not go over tonight. and some just to be certain, okay? So where did we stop back here? Who's next? Because they're not here, you're next. Okay. \n, \t, \0, and there are others. What are those called? We used in string expressions. Sorry?
The first one is the new line, second one is.
Wait a second, I'll ask you after I finish with him. Go ahead, sorry?
First one is a new line,
That's a new line.
it's a tab,
It's a tab,
and a blank space.
and this is a null. What are these things called when you use them inside of a string? Okay, behind them, what are those things called when they're used inside of a string? Okay, starting at this end of the first row. What are these things called inside of a string? Is what you all want to do tonight since it's 9:20. Put your hand down, please. I'll call on you when I'm ready.
Endpoint?
Escape. You all want to escape. These are escape sequences. Okay? In other words, they have special meaning because they are preceded by a backslash. Yes, sir, in the back. Question. Who had his hand up? No question? Okay. In this, next person, void main, paren, open braces, close braces. What does this / star do?
Comment?
Okay. Will this code compile?
No. Because
Why?
you didn't close, you didn't do // so if, for this version of the comment, you have to close it with, what is it, //?
That's right. You have to close it with //. Comment that begins with /*, you close with //. Next person. What is this?
Comment.
Comment. Where does the comment end?
Whenever you put anything after the two backslashes, everything in that line is comment.
It ends at the end of the line. So that's the difference between /*, which has to be terminated with a //, and just //. So know what those comments are. Next. This piece of code, y is equal to 13, y star equal to. At the end of this code, what will y equal?
Y will equal to 26.
Why?
Because on the first line of code, that's an assignment operator, you're assigning the value 13 to the variable y. And then on the second line of code, what you're essentially doing is that you're multiplying 13 by 2 and then reassigning that back to the variable y.
That's, to be more specific, you're assigning what is already, you're multiplying what is already in y by 2 and then assigning back to y. But that's essentially correct. Next, in this piece of code, x is equal to 3, x is equal to plus x, sorry, y is equal to plus x, and then z is equal to x plus plus. Okay? What will y equal to? What? At the end of this program, what is y?
3.
Y?
It's adding the value. It's setting itself equal to y plus x.
Nope,
It's y plus.
it's not 3. At the end of this little code sequence, what is y equal to?
4.
y is y equal to 4?
Because it's essentially adding one for variable x.
Because the plus plus is before x, it does the addition to x first, and then assigns it to y. Next, what is z equal to at the end of this sequence?
Would it be 3? Oh, Z or 3?
So hang on. Just so you know, x is equal to 4 at the end of that assignment statement. What will z equal to?
3.
Why would it be equal to 3? X is equal to 4. There's no subtraction going on here.
Because it calculates the Z equals X first before it computes the plus plus.
Yes, but what is x equal to?
I didn't know we were following the same. Okay,
No,
yeah,
it's the
4.
same,
So 4.
following the whole thing.
4.
Okay. Z is also equal to 4. At the end of this, what is x equal to?
At the end, X is equal 3. Or
The whole sequence. All three of these
X
things
equals
are
4.
executed.
4.
Is equal to 4?
I believe so. Says
What
Z
about this
equals
plus
X.
plus?
I don't know.
The location of the plus plus determines when it happens. If the plus plus is in front of the x, x is incremented before it's evaluated further. If the plus plus is after the x, it is incremented after x is evaluated. That is why z is equal to 4, because x was equal to 4, and it's evaluated and assigned before the increment happens. But the increment still happens. So x will equal 5. Okay? This is implicit homework from the first night. Next. Who's next? Next. He's writing notes. You. Okay, finish your notes. I like people taking notes. I'm happy about that. It's a good thing.
What's the question? Or do I have questions?
Yeah, I got one for you after you're done writing that note. Okay. Percent F, percent D, or what?
Formatting specifiers.
They are formatting specifiers. See the value of taking notes? What's another name for formatting specifiers?
Placeholders.
Placeholders. The value of taking notes. Guys, knock it off. Guys, out in the hall. Take it out in the hall if you need to have a conversation, because we're busy reviewing for the test. If you want to have a conversation, that's fine. Go out in the hall and have it. Okay?
It's helping them explain the last.
You need to have a conversation out in the hall. Everybody from now on, right? Or else you'll be dismissed for the evening and miss that information. There's 70 people in here. Suppose we had 35 conversations. How practical is that? You're college students. Start thinking and acting like it. Okay? All right. Formatting specifiers and placeholders. Okay? What are they used in? What method call do they use in? The formatting specifiers.
That calls like scanf.
Scanf? What's the other one? Scanf was to read things in, or you used to write things out.
Printf.
Print.
Yeah.
That's right. Okay? Know the other ones, right? The numeric ones. %F, %C, %D, %I. There's a few others, right? You have to know the main ones. White space. What is white space?
white space is any space that doesn't have a variable or character filling it. So in the compiler, I think you said it all gets smushed together.
As far as the compiler is concerned, 5 spaces is the same as 1 space. Tabs is the same as a space. Character returns are the same as the space. So that's what white space is. Character or white space are spaces, tabs, and new lines. Okay. Next question. What about white space within quotes, within double quotes? Is that considered white space, or are those considered valid characters within double quotes?
You said in double quotes?
Within. Suppose I wrote and then I did a printf. Well, let's suppose between the B and the X, those are 5 spaces. When it prints out, would it have 1 space between the B and the X, or would it have 5? It would have 5. Because ignoring white space is only true outside of quoted strings. Other than that, white space is all treated as a single space. Arithmetic operators. Name some.
Plus, minus, asterisk for multiplication, quarter slash for division.
There's another key one. Not key, but another.
Percent for mod.
Percent for modulus. What is modulus?
Is this space the remainder?
It is the remainder. Exactly the right word. Okay? All right. Let me make sure. One more time. Plus everything else we covered tonight. Either in review or new. How much am I bid for the exam? Just kidding. Sadly, that's a true statement, not from the professors, but from other people. At UCI, I'm certain of, and possible here. Okay, that's it? Any questions? Hang on, everybody, hold on just a minute. Is it a general question or?
Over here.
Go ahead.
So, Professor Lang, for x equals 3, y equals club plus x, if z equals club plus x, would x equal to x is 4 on the top?
This is 5.
It's still 5.
After this statement, plus x, x take on the value of 4.
Okay.
And after the plus, we're going to make x take on the value of 5.
But if you change it like plus x for z, would it change the x's?
Let's talk about it. Okay.
Oh.
Everybody, go ahead.